Right, so this one's on kinematics, which is physics. For any of you here doing that. So number 1, displacement versus distance. They're actually two different things. So displacement is the position of a particle relevant to some other reference point. So displacement equals position, whereas distance is like the total space covered. So we've got our scale here. Start at 0, 1, 2, 3, 4, 1, 2, 3, 4. So we've got a particle. It's going to start at 0. That's our particle there. And it's going to travel towards 4. And then it's going to stop at 4 and then travel back the other way to -2. And it ends there. So the difference between displacement and distance, displacement is its position at the end compared to its position at the start. So its position at the start was 0 and now it's at -2, so its displacement is its position, it's -2. Whereas the distance that it has covered has gone from 0 up to 4 and then back down to -2. So 1, 2, 3, 4, 5, 6, 7, 8, 9, a total of 10.
Is there units on that? Or is it like,
if there were units, you would say like 10 centimeters, but
so say if it was meters, it'd be like
10 meters, yeah. But there's no units in this question, so
Yeah, right.
yeah. So that's the difference between displacement and distance. Difference, yeah. So displacement is its position, distance is how far it's traveled. Okay, next one is velocity versus speed. So the average velocity, we've got two different types of velocities and speeds. There's average and there's instantaneous. So average velocity is actually the change in position over the change in time. So in other words, it's the displacement over time. And average speed is the distance over time. So obviously from the differences between displacement and distance, that's the same difference between velocity and speed. Is that velocity is talking about displacement, the position, and speed is talking about the distance, the total distance covered. So we've got our scale here again. 1, 2, 3, 4. 1, 2, 3, 4. Say our particle starts at 4. So that's at time equals 0. So starting there, and it's traveling down to -3. Stops and turns back, goes to -2. At this point here, it's 3 seconds. And at this point here, it's 4 seconds. We'll give this one a unit. It'll be in centimeters. We'll say 0 seconds. So the average velocity displacement over time. So what's the displacement? -6. Explain it. Oh, it's went dark. You do the difference between the end value and the start value. So the difference, it ends at -2, and the difference is minusing the start value. So that's how you get your -6. Your end position minus your start position. So the end position is -2, you minus the start position, which is 4, you get -6. And it's over a total of 4 seconds. So yeah, -6 over 4, which is -1.5 centimeters per second.
Going back.
Yeah, it means it's going, well, for the most part, was going to the, on my page, left. Okay, the average speed. Right, speed is the total distance. So the total distance that it has covered, it's gone from 4 down to -3. So that's a total of 7 plus another 1. So it's gone a total of 8 centimeters over 4 seconds. So that's 2 centimeters per second. Okay.
Because I don't really get, like, what is velocity? Like, not in these terms, but just in general. I don't really understand, like, what it.
Right. And we've got the instantaneous velocity is the rate of change, i.e. gradient, at any given time. I.e. like at a certain x value, what's the gradient at that point? That's the instantaneous rate of change. So i.e. velocity equals dx dt, where x is a function of time. Right, so it just means you are taking your x value, so its position, and you're just deriving it over in terms of time, which we've seen before. If we want to know the gradient at a certain point, take the derivative of it. Okay. So instantaneous velocity just means the instantaneous gradient at a point. Okay, last one is acceleration. So we've got average acceleration at acceleration. Acceleration equals the change in velocity over the change in time. So basically you take your v2 minus v1 over your second time minus your first time. So it just means like the velocity at the end value minus the velocity at the start value over the time at the end minus the time at the start. Whatever your two reference points are.
So it just change.
It's basically just your average rate of change is that average gradient.
Pretty much changing velocity.
Yeah,
changing.
Exactly. Yeah. Not quite the average because it's over. It's like the average gradient. It's not at a certain point. dv dt is for instantaneous, which is what we're about to do. Instantaneous acceleration equals the derivative of velocity. In other words, dv dt. dv. Right, the derivative of velocity in terms of time. But of course, velocity is the derivative of displacement. So you can say it's the derivative of the derivative of double derivatives. That's what we're going to head into. Yes, it's actually the derivative of velocity. In other words, it is d dt of dx dt.
D squared x dt.
Yep. Right, if you treat that kind of as regular fractions and multiply them, you get d squared x over dt squared. Don't worry too much. It's basically just the notation. Like that is how.
D squared, T squared.
Again, it's just like a notation thing because d is not an actual like term. It's just like a symbol that means derivative.
Why not D squared? Yeah.
That's what I'm saying. Like it's not. It's kind of hard to explain. I've never really fully understood it myself. I just kind of took it at face value and said, okay, that's how we explain the double derivative. So that just means the double derivative. Just remember that notation. We can definitely look into it together, but yeah, I'm not actually sure why it's written that way. 100% sure. Okay, so in summary, we've got, you can also write this if you've got a function, say like f of x, you would write the derivative as f double dash x. The double dash just means the double derivative. So what you've done is just take the derivative and then you take the derivative again. It's not hard. It uses the same derivative rules. You just do it again. So in general, we've got displacement. Would be f of x. Well, we'll just call it f of x. Why not? So displacement is just like a function. Velocity would be the gradient of that function. And acceleration would be the derivative of the function.
Okay.
Yeah. For instantaneous, it's different if you're doing average. And because average is like over 2 reference points is average.
So finding the double derivative.
We sure can.
So like if you had like you go like
Yep.
and that's like whatever the question was before.
Yep.
Something like y equals x cubed minus 6x squared plus 12x plus 12.
Yep.
Find the derivative of that. You find the derivative of that derivative, which equals b side.
Yeah. We got x squared plus we'll do 4x. Okay, here's a nice long one. Right, how do you find the double derivative? Well, first find the single derivative. The first derivative. See it? 12x cubed plus. Yep. 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 Do it again. So you just take the derivative of the derivative. So yeah. Yeah. That's all it is. You can find the triple derivative.
What would that equal, Miss? Like accelerate? It's not really accelerate.
It's not. It's nothing with
Don't feel like
kinematics.
meters per second.
Accelerate.
Meters per second per second per second.
Yeah.
Sure, why not?
What is that?
I don't know. I don't think it is anything.
So,
Right, plus 3. Let's find the fourth derivative.
In the first second.
I think sometimes they might write that, if I remember from uni, like write that like that. F to the 4. Can't quite remember though.
Means what you need to do.
F to the 5, deacon.
0.
0. Can't go any further than that. There you go. That's all you have to do, just keep doing derivatives. Again and again.
So like, why